All right, so I'm going to go through this pretty quickly. We're only going to go through the 5 review questions. For this one, using quadratic formula, you will be given x is equal to negative b plus or minus the square root of b squared minus 4ac all over top of 2a. You will be given this. So you do not need to memorize. Right now, what we need to do, though, is figure out our a, b, and our c. And to do that, we need to write it in standard form. So we need to set it equal to 0. So we'll subtract 8x. And it's important that you have 12x squared minus 8x plus 8 is equal to 0. It must be written in this order. All right, so now if we look, all of these are divisible by 4. So I can factor out a 4, and now I'm left with 3x squared minus 2x plus 2 is equal to 0. Then I can divide each side by 4 to get rid of that GCF. And then I get 3x squared minus 2x plus 2 is equal to 0. If you did not do that step, it's not that you would get it wrong. It's just you're going to be dealing with much larger numbers, and multiplying them could be a little bit challenging without a calculator. Now that we reduced and took out our GCF, our a is equal to 3, our b is equal to negative 2, and our c is equal to 2. Now we just plug it in. So negative b, so it's negative of negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a times c, so times 3 times 2, all over top of 2 times a, which is 2 times 3. All right, so now I'm going to do everything inside the radical. So this will then be square root of negative 2 squared is 4. Minus 4 times 3 is negative 12, times 2 is negative 24. And then that will reduce to negative 20. So then we have positive 2 plus or minus the square root of negative 20 over top of 6. Right. Then our last step is we will have to reduce the square root of 20, negative 20. So first off, I can make this positive because I know that this is the square root of negative 1 times the square root of 20. And the square root of negative 1 I know is equal to I. Then I need to simplify the square root of 20. Well, 20 can be multiplied by 4 and 5. I know the square root of 4, that is 2, so I can take that out, and this 5 will remain inside the square root. So now I can simplify this even more by x is equal to 2 plus or minus 2i times the square root of 5 all over top of 6. All of these numbers, 2, 2, and 6, are all divisible by 2. So I will go ahead and divide each of these by 2. And then I get x is equal to 1 plus or minus I times the square root of 5 over top of 3. And that would be your final answer. All right, so for this one, we've done this a few times. So once again, I'm going to go through it pretty quickly. But this was also on our last test. So the very first thing that we do for this is we're going to put in parentheses the x squared and the x. And the constant, this gets written by itself. Then if there is an a that's other than 1, so the number in front of the x squared, if it's something other than 1, that gets factored out. So y is then equal to negative 2 x squared. Now the problem is a lot of you guys, when you factor out the negative in your test, you did not change the sign, so it's plus. And then this is 12x, leave a space, minus 71. Right? Some of you guys, then after you did this step, you took this minus 24, and that was the number you divided by 2. Once you take out your GCF, the number in front of your x, so your b in that case, is going to be the number that we use. So we do 12 divided by 2, that is 6. We square it, so it's 36. So we add 36, and now we think, this is actually being multiplied with negative 2. So we are then subtracting 72 here. So we're not actually adding 36, but we're subtracting it. So then to offset, I'm sorry, we're not actually adding 36, but we're subtracting 72. So to offset the subtraction of 72, we need to add 72 because 2 times negative 2 times 36 is the same as plus 72. Now we can factor y is then equal to negative 2. This will always factor into binomial squared plus 1. Well, binomial squared, negative 72 plus negative 71 plus 72 is 1. Now this factors into the square root of the first and third, so it's x and it's 6. The sign that we have here is the sign that we put here. All right, now we create our table. Our vertex, this tells us we're moving to the left 6, and this tells us we're moving up. So that means our vertex is negative 6, 1. So I plug that in the middle. Then I need to pick two numbers that are greater than and two numbers that are less than. So -5, -4, and -7, -8. When we plug in -5, it will then be -2 times -5 plus 6 squared plus 1. So -2 times 1 squared plus 1. So -2 plus 1, so -2. So if this is -2, I also know this one is -2. Then the next one, it'll be plugging in -4. So it'll be -2 times, let me use a different color since it's right next to the green already. So I'll use this blue. So -2 times -4 plus 6 squared plus 1. So this will be -2 times 2 squared plus 1, or -2 times 4 plus 1, -8 plus 1, or -7. So when x is -4, y is -7, that means this is also -7. Now we just plot the points. -6, 1. So 1, 2, 3, 4, 5, 6. Up 1. I know since this is negative, I know my graph's facing downwards. So a lot of you guys are making mistakes, even though that we know that this means we're reflecting. Right? Then it is -5, -2. Because I know that my graph is symmetrical at this point, I can use that to quickly graph some of my other points. So I know that this one is also going to be at -2. And then at -8, it's -7. So, or I'm sorry, -4, it's -7. 1, 2, 3, 4, 5, 6, 7. That's at -4, -7. So this one's also at -7. And now we will just draw our graph. I know I made this graph pretty small on your paper. On your test, it won't be as small. All right, that is it for this. You will get points for being able to write it like this. You will get points for creating this table, and then you will get points for drawing your proper graph. All right, so for this one, I may need to move the screen around a little bit because it's a lot of writing. But we know when we're solving for our x-intercept, y gets set equal to 0, and for our y-intercept, x gets set equal to 0. So we can solve these ones pretty quickly. It's easier to solve for this y-intercept. So our y-intercept, we know that x is equal to 0. So when we plug this in, as we talked about before, when it's in standard form, it's just going to be your constant. So this y will then be equal to -3. So we said x is equal to 0 already, and our y is -3. So we can plot that point, 0, 1, 2, 3. There's our y-intercept. Our x-intercept, we set y equal to 0. So now it's 0 is equal to x squared minus 2x minus 3. And we solve. You can use any method you want, but this one factors. It factors out to x minus 3 times x plus 1. So x is then equal to 3, or x is then equal to -1. So we set our y value as 0, so I know it's already going to be a point with 0 for y. Well, we said x is 3, and it's also -1. So we can go ahead and plot those points. So 3, 0, 1, 2, 3. I'm trying to keep them in the same color I'm working with it so you can follow along. -1, 0. Our axis is symmetry. So for C, we know we're going to use the formula x is equal to -b over 2a. Right? You will get this formula. So x is then equal to, well, first we need to figure out what is our a. Our a is equal to 1. And our b is equal to -2. So it's negative of -2 over top of 2 times 1. So x is equal to 2 over 2, which is 1. So our axis of symmetry is x is equal to 1. So along this point where x is 1, I can draw my dotted line, which you must draw. All right, now to know our vertex, we know our vertex has the point 1 because we already found our axis of symmetry. If we know our x value of our vertex, to solve for the y, we plug it in. So y is equal to 1 squared minus 2 times 1 minus 3. So y is then equal to 1 minus 2 minus 3, or y is equal to -4. So our vertex is a point -1, or 1. It's 1, -4. I'm sorry, I just realized now I made a mistake. Hopefully you guys caught that on video, but 1, -4, 1, 2, 3, 4. My y-intercept was not 0, 3 like I wrote here. I'm really sorry. I'm just trying to get through this quickly, but 0, -3. So it's 1, 2, 3 here. All right, so now, based on this symmetrical property, I know that since I'm one space away, I'm at -3 here. I know one space in the other direction, I'm also at -3. So I can fill in that second blue point. And now I can draw my graph. So on your test, I do want you guys to use your axis of symmetry and your reflexive property to go ahead and fill in your graph a little bit easier. All right, let me just draw this a little bit better. All right, so there's our graph. I know the graph is pretty small here, which makes it difficult to graph. All right, this one is the exact same thing. When we're solving for our x-intercept, y gets set equal to 0. When we're solving for a y-intercept, x gets set equal to 0. So to solve for our y-intercept, because that's the easiest, we can do that first. So x is equal to 0. So right away, I know this has a point of 0 something. And for this one, I know I can have a point of something 0 and possibly another point. It may only be one intercept, it may be two, or it may be none. But if it's going to happen, we will have 0 as our y value. So then we just plug in 0 for x. So y is then equal to negative 0 squared minus 8 times 0 minus 15. So y is then equal to negative 15. So our point is 0, negative 15. All right, I just realized now that I didn't give you a big enough graph, so I'm going to count by twos. So this would be 2, 4, 6, 8, 10, 12, 14. So 15 will be directly in the half, right in the middle. All right, so that is my y-intercept. My x-intercept, I set our y equal to 0. So then it becomes negative x squared minus 8x minus 15 is equal to 0. We factor out the negative. Then we divide each side by the negative 1 to get rid of it. So I have x squared plus 8x plus 15 is equal to 0. We factor. It's x plus 3 times x plus 5 is equal to 0. And then when we solve this, x is equal to negative 3 or negative 5. So that means our x-intercepts are negative 3 and negative 5. So we can plot these. So my y is counted by 2, my x is counted by 1. So 1, 2, 3, 4, 5. So those are my x-intercepts. My axis of symmetry. I know that it is going to follow x is equal to negative b over 2a. My a in this case is equal to negative 1. My b in this case is equal to negative 8. If you wanted to make it positive first, you can. But you don't have to. So then it's x is equal to negative of negative 8 divided by 2 times negative 1. So x is equal to 8 over negative 2, which is equal to negative 4. So our axis of symmetry is x is equal to negative 4. We can also solve that by knowing our vertex has to fall directly in the middle of our two x-intercepts. And it's pretty easy when they're only just one space away or two spaces away. So I know that my vertex falls somewhere along this green dotted line. So I know it's negative 4, I just don't know the y value. To solve for that, we just plug it in. Y is equal to negative 4 squared minus 8 times negative 4 minus 15. Well, y is then equal to negative 4 squared is 16, and 16 times negative 1 is negative 16, plus 32 minus 15. Negative 16 plus 32 is 16. 16 minus 15 is 1, so my y value is 1. So it's negative 4, 1. So now using my symmetrical property, I know that this point is 1, 2, 3, 4 away. So that means when it's 4 away in the other direction, it's also the same value, 1, 2, 3, 4. So I can use my symmetrical property to fill this in, and then I can draw my graph. Once again, this graph's a little bit harder for me to draw on this pad, and being so small, you will have a bigger graph on your test, so you'll be able to graph it a little bit easier. And that is your graph. All right, we had our y-intercept here at 0, negative 15. We had our x-intercepts at negative 5 and negative 3. And then we had our axis of symmetry and our vertex here at negative 4, 1.